All right, time to move on. So we have the square root of 32. In order to simplify that, I'm going to break that down to 8 and 4. I could also see that as 16 and 2. And that's what I want you to condition yourself to do. Try to find yourself a nice round square. Because as soon as I do that, the 2 doesn't go any lower. And this becomes 4 square roots of 2. So it makes this much simpler. Coming over here, I could have broke that 8 down to 4 and 2. Now I have a pair of 4s. Those come out in front. And then it's the square root of 2. So it's the same answer either way. The only difference is on the first one, I found it a lot faster. Next one. If we're looking at the square root of 196, I need to find numbers that multiply to give me 196. There's actually a trick to this one, and it's the fact that it would be 14 and 14. 196 is a perfect square. So since that's a perfect square, I'll have my pair right now, and there's nothing left inside. It's just 14. So anytime you have a perfect square, when you do this, your answer is just going to end up being whatever number that is. It gives you 196 squared, or whatever number you square to get 196. So it's just a couple more examples of how we can simplify roots. That leads us into our new topic, which is that we're not allowed to have a root in the denominator. So to fix this, we do what we call rationalizing the denominator. The easiest way to do it is to simplify the denominator first, then multiply both the top and bottom by the root from the bottom. That can sound confusing now, but once you see it, it's not too bad. I'll give you guys some time to write that down. So what this means is we should first start by simplifying this square root of 50. So let's break that down. What multiplies to give us 50? 25 and 2 would be easiest. 25 is a perfect square, because 5 squared is 25. So the square root of 50 is really just 5 square roots of 2. So once I know that, I can replace this square root of 50 with 5 square roots of 2. So 4 root 35 still over 5 square roots of 2. Now we still have a square root in the bottom, and we're not allowed to have that. So in order to fix that, we multiply both the bottom and the top by the square root of 2. What that'll do is in the bottom, that would make that the square root of 4, which is just 2. So the bottom would turn into 5 times 2. So that gives you 10. Everyone understand that? So that gives us just 10 in the bottom, because that would really be 5 times the square root of 4, 2 times 2. because they're both under roots. Square root of 4 is 2. 5 times 2 is 10. So that's how we get this 10. On the top now we multiply what's under the root times 35. So that gives us 4 roots of 70. Good. Can we break 70 down in any way that'll work? So I don't think we've had a situation where we weren't able to do anything with it. But with 70, if I break that down, that's 7 times 10, and that's 2 times 5. So I don't have any pairs in the problem, so it doesn't break down. It just stays as the square root of 70. So this is our final answer. Anybody have any questions on that? We're going to work through a bunch more just so we get extra practice with these. So if we're looking at this one, if I break down 6, it's just 3 and 2. Can't do anything else with it. So I don't really even have to break it down. I can't have a square root of 6 in the denominator, so I got to multiply both the top and bottom by the square root of 6. On top, that gives me 10 times the square root of 12. On the bottom, this is going to get rid of my square root, and it's 10 times 6. In all actuality, I could have started this problem by canceling the 10s out, since it's the same thing. 10 divided by 10 is just 1. So right now I'm left with square root of 12 over 6. Now we can break the 12 down to simplify that. What's going to multiply to give us 12? Six and 2. And then what's the 6 break down to? Yep. 3 and 2. Now have a pair. That comes out in front. 3 stays inside. It's 2 root 3 over 6. Is that in simplest form yet? Yes. Short. Go right ahead. No, Janae, I should make this clear. So this is not in simplest form yet, because 2 and 6 can be reduced. 2 over 6, what'd you say? Yeah, we don't have a square root on the bottom anymore, right? Yeah, we can have it on the top. The only thing here is 2 over 6 reduces to 1 over 3. So it's just going to become root 3 over 3. That's your final answer. The only issue was just that it was 2 over 6. We can reduce that further. All right, try to do the next one. See if you can figure out what to do with it. What would we have to do first? Right. And we wouldn't factor the 6 out just because it's outside of the root already. So, and the only time we have to worry about that is if it's inside the root. But you're right. Multiply square root of 5 on the top and the bottom. Yep, that's right. Now on the bottom, this is going to become, if it's square root of 5 times square root of 5, that becomes the square root of 25, which is just 5. So basically, whenever you multiply by this root on the bottom, you can just cancel the root out. So whatever's left in there stays. So it would just be 6 times 5 on the bottom. Then if we try to simplify the top, that only breaks down to 3 and 5. So there's nothing we can do. So this is our final answer. Let's try this next one. I will warn you, there's kind of a trick to this next one. Does anybody see what the trick is? Well, this one's not under the root, so it just stays. We don't do anything with it. But this one, you're exactly right. This would just become a 3. So our top just turns into 9 times 3, which is 27. So if we start by simplifying that, it makes it easier throughout the rest of the process. Right. But we have to get that square root off the bottom. Yep. Yeah, do the same thing we've been doing. This process here was, instead of multiplying the square root of 5 up to here, if I just do the square root of 9 first, if I break that down to simplify it, it gives me 3 and 3, because 9 is a perfect square. So the square root of 9 is 3, so I just did 9 times 3. And that's how I got to 27. All right, what do we multiply by to get the square root of 5 off the bottom? Yep. What would we be left with on the bottom here? It would be the square root of 25, which just becomes, yeah. And then on the top, 27 times the square root of 5. Because this isn't under a square root, we keep those separate. And that's our final answer. All right, last one for the day. This one also has a trick to it. Close. Right. So that gets rid of the root. Yep, exactly. 4 times 2. Yep.